Hey everyone, it's Rich from Dashboard Gear and back again for another session on SQL. This will conclude our episodes on the SQL. The title I put on the slide up here, Advanced Miscellaneous SQL, we wrestled round and round with what to call this session. Because any of you that have done SQL know that what does advanced SQL mean? It can mean a lot of different things. As we're progressing through your knowledge journey, you'll soon learn that SQL is a lifetime of learning. I'm constantly learning new things with SQL. And so for those of you that are pretty experienced on SQL, you might look at this session and say, those aren't advanced topics. And for those of you lesser experienced, you'll view these as advanced topics. So I'm just gonna get that kind of weasel words out, excuses out of the way right away by just saying to some of you these might be advanced and some not, but we'll just kind of dive into them. I'm going to talk about just 5 topics today. We could go on and on for hours on end. We do half-day SQL classes that go through a lot of the details on SQL as well. So that's where we can get really deep, but I'm just going to stick with 5 topics that I think will benefit those of you doing reporting and business intelligence. So with that, I'm going to start with reviewing the basics of a SQL statement. So just kind of catching everyone up with what we've done the last few weeks. So the first week we talked about basic SQL, and we went over how a SQL statement is basically a select statement where you list the fields that you want to return, or what are the values you want to return from, which is the tables that you're bringing data back from, and then where, which is the filter criteria that you're going to put on that. And then last week we progressed to go through how do you join in additional tables through what are called joins. So we went through joins last week. This week I'm not going to cover joins too much, other than I do have them in a couple of my examples. So that will bring that in there. All right, so I'm going to dive right into topic number 1, which is aggregations. In aggregations, we talked about summing and counts. Aggregations are ways that you can return totals of things, counts of things, a number that's a calculation. And so what I've got here on this first example is a select where I added a sum of hours as total hours. Now in this, I want to highlight a couple things. First thing you do is you add the calculation that you're going to do to your select statement, because it's just another column. So in this particular result, my result set would return 4 columns of data: the employee, the position description, and the total hours, which is just the total for that. Now, what total hours is it returning? And this is really where the key thing comes in when you start to get to aggregations. Whenever you add an aggregation to your select result list, you have to have a group by clause at the bottom that's telling it the columns that you're grouping it by, or what are the columns you want that. Now, SQL has a limitation in that, or a qualification, I'll say, in that you have to include in your group by all of the columns from your select list that aren't part of that aggregation. So for instance, in this example, in my group by, I have to return employee, position, and position description. So what this total hours will be is the sum of the hours for each employee, position, and position description combination. So if an employee had 2 positions, you're going to see the total hours for position 1 and the total hours for position 2 on the second line. So it's going to group it by each position. Now, what I did was I took one of the queries we did last week, which was a join where we joined employee to position. In this case, I inserted a payroll table from Info's payroll system called PR time in between, where I'm taking every employee and joining them to the PR time record for their employee record. So giving me all the time for that employee, and then turning around and joining that to the position. By doing it this way, it will account for multiple positions. Now, I'm going to go ahead and hit escape on this PowerPoint, so it's going to look a little bit more abbreviated for you. But the reason I'm doing that is it's going to allow me to play with this grouping a little bit. Just to highlight some things. if you want a total of the time for every position, regardless of employee, if you think of that, all you're going to do is remove the details that you don't want that by. So in this case, I want it select for every position, the total hours, and then the corresponding group by clause to change that as well. So right now it's going to give me the total hours for each position instead of by employee for each position. So just know that by messing with the group by clause and the select, it's going to give you different totals based on different things. So that's really the combination of aggregations. Now, you're going to see different aggregation functions available depending on what database engine you're using. Now, the basics of ANSI SQL has some common ones you're going to see. Now, you're going to see some a lot. That is by far the most common. The second most common one is count. Maybe you want a count of records. You can also do things like average. There's a min, which is the minimum value, and max, which is the maximum value. So just know that you can use any of those aggregation functions, but the group by function works exactly the same. Now, if you want to add qualifications into a query, normally when I'm adding filters, like in my example before, I would do where, company equals 1, let's say. And I know I need to put E on there because I need to specify what table, because company goes in more than one table here. So I would say where E.company equals 1 would filter it for just company is 1. But let's say I wanted only the items where the sum of the hours was more than 100. You can't just put in down below here and total hours is greater than 100. SQL doesn't know how to handle that as part of the aggregation. So anytime you need to add a filter or criteria to that aggregation, instead what you need to do is, I'm going to copy that down there. We need to add what's called a having clause. So it's grouped by the same fields, but having a sum of total hours greater than 100. So it's basically you add having and then your aggregation repeated with what the value is. So slight difference on the filter. Instead of in a where, if you're filtering on the total, you use what's called a having clause. So that's just one of the uniquenesses of that filter. All right, so that's about as much as I want to say about aggregations. Those of you that have questions on that and want to comment in the YouTube comments or ask questions that way, feel free to do that as well, and I'll try and reply to them in there. Now, the next topic I want to get into is what's called a union statement. There is a use case where you could have multiple queries and you want to bring those together. So I added a very simple query here where I said select ABC as a field value, and then I said union and select DEF as a field value. I have two distinct queries, but I want to bring those together into one result set. So maybe you want to select all the jobs from employees, or that's a better one. Select all the birth dates from employees and all the birth dates from dependents. Two separate queries, but I want to just have a listing of all the possible birth dates. That's one way of doing it. Now, the qualifications on a union is that each of the queries has the same number and type of columns. And so what I mean by that is this first query has one column and the second query has one column, and they're both strings. Now, this also is demonstrating something which I have not shown you previously, and that is a literal value. So in this case, if you use single quotes on a value, that means a literal value. So in this particular case, I'm doing select ABC as a field value and select DEF as a field value, and that will union those two together. Now, the result of that from a union is a result set like you'll see down below here, where I've got two records are returned, ABC and DEF. And that's what a union does, is it just puts them together. Now, there's another clause I added up here um, called union all. Now, to demonstrate what union all is I'm going to show you here that same item where I said select ABC union, select ABC. You'll notice they're the same values. The result is only one record. What a union does is it eliminates all duplicates from that common result set. So there's a singular record. So in my example of select birth dates from the employees and a union select birth dates from dependents, what that would do is eliminate any duplicate values across those two result sets. So it would just be a single record. Now, if I use union all in that example, by adding the word all there, it's going to include all records. So in my example here, both the duplicate items would show as separate rows. So it will include that. So the difference between them is union will get rid of the duplicates. Union all will still include them. There is a performance penalty to use union versus union all because the database engine obviously has to decide what's a duplicate. Versus union all, it's just going to start spitting out the results together. So it's a little bit faster to do union all, but just depending on what you need in your result set to do that. So that's a union statement. Very powerful to bring records from two different queries together into one. And I use this a lot on the financial systems, for instance, where maybe I want all the records from PO and all the records from AP and all the records from inventory or requisitions. You can do unions with separate queries just to bring those together as one. So that's just a common kind of use case on that. Now, the next operator that I'm going to show you on the SQL side is an in statement. And what an in does is a comparison of multiple values rather than single. Now, I showed you in that query on the filter in the where clause, we said where company equals 1. You could say where employee equals 10 or whatever. In an in clause, it's a list of values. So it's where employee status is in A1, A2, and A3, which means it will return any employees that have a status in A1, A2, and A3. So it's a combination of values within that. So that's what an in clause is. Now, another operator that's similar to in is the like operator. Another very powerful clause where you want to say, I want any values where they're like something. So in my example here, I said where employee status is like a percent. And what this means is I want any employees that start with A, meaning this percent sign is a wild card. So it would be A and then any combination of characters afterwards. Now I could put AB here, and that would be any statuses that start with AB. Or I could say percent AB, and that would be any statuses that contain AB. Doesn't care what's before it or what's after it, it's going to be AB. So you use this wildcard percent as a way of filtering those out for you based on that. So that's what the like operator is. Now, the last item I'm going to cover in today's session is a conditional value list. So oftentimes you want to take a value that's from the database and switch it to something else, or you want to compare it to something in a list. So the statement used for that is called a case statement. And the syntax on a case statement, in this particular example, I'm returning employees, but then I'm adding a case statement where I'm saying case when the employee status is like a percent, meaning it's starting with A, then active. And I made a literal value of active. When employee status is like T, then terminated. Else, I'm going to say unknown status. Then I say end, and I give it a field name. So this would return active for any employee that starts with A for their status, terminated for any status that starts with T, or unknown if it's anything else. Now, it's a good practice to always include an else statement in your case statements to account for anything unexpected. So I accounted for the A's, the T's, and then everything else I'm saying is unknown. not really a reality probably in this case, but that's just an example of how you do it. And just remember to end it with an end statement. And you always have to alias one of these case statements with an employee status or with a field name that you want to call it. So that's an example of a case statement where we're going to go through and compare different values and give it an alternate name or an alternate value. All right. That's really all I wanted to cover today from an advanced or miscellaneous SQL thing. Just know that there's so much you can learn about SQL. It's going to be an ongoing learning. There'll be things like subqueries, which I didn't get into, which is a query within a query. You can do things on the where clause, like where exists and where in, which are just queries that qualify the query further with another query. So you get into a lot more things that way. So if you do want to explore that further, continue your journey on learning SQL. Now, next week's session, I wanted to apply it more back into the world of Infor S3 reporting, which I qualified it here as by saying the old Lawson system. What we're going to try and do is build a P&L against Lawson data using Crystal reports. So on our financial customers, just pure P&L. We'll go through the process of what it takes to build that, the things that people struggle with typically in doing that process. I'll go through that, and then just different layout options. And then I'll probably go through some different distribution items related to that as well. So I want to thank you for joining today's session. And just like always, if you have any suggestions, feel free to email those to info@dashboardgear.com. We'd love to incorporate those into a future presentation. Or if you have any questions at all about Dashboard Gear or how we can help you, feel free to do that. And it really also helps us if you like the video down below and subscribe if you would like some future information about sessions and so forth. You can subscribe to both YouTube as well as our Facebook channel. So thank you for joining us today, and we'll see you next week.